Hi, everybody. I'm going to pick up now at number 10 on our review. And so let's take a look here. What is the value of D in the attached table? So when you're looking at this, whenever you have a table like this, the top number here is your input value, and the bottom value here is your output value. So when you're trying to find out a missing value in a table, you have to figure out, is there a pattern here? How do I get from 405 to 9? How do I get from 45 to 1? From here to 3? From 270 to 6? And it has to work every single time. This one right here is going to be our secret because notice it's the unit rate. We have the price, the unit cost is $45 for one video game. So for 9 video games, if it's $45 for one, does 45 times 9 equal 405? And yes, it does. 9 times 5 is 45. 9 times 4 is 36 plus 4 is 40. So we have $405 for 9 video games. So technically, we're dividing by 45 to get from here to here. Same thing here, 45 divided by 45 is 1. 270 divided by 45 is 6. I could write a rule for this. I could say the video game price, let's call that V for the video game price. It or the number or I'm sorry, the number of video games is equal to the price in dollars divided by 45. Okay, so the number of video games V is equal to the price in dollars divided by 45. To answer this question though, reversing that would be easier. To get from 1 to 45, I can multiply by 45. So to find D, I should be able just to take 3 and multiply it by 45. And we get 15 here, carry the 1. 12 plus 1 is 13. So it's 135. That's what goes in here in place of D. $135 for 3 video games. So D equals 135. All right. Number 11, Marcus ran 2 laps around the track in 3 minutes. You can see the laps here is your input. And the time in minutes is your output. The input, you could also call that your X value. If you're graphing it, it goes along the X axis. The number of laps, see how it's along the X axis here and here? The output value is your Y. The time in minutes, see how it's along your Y axis here? Along your Y axis here as well. So we want to find a graph where 2 laps takes 3 minutes, 6 laps takes 9 minutes. I bet you could fill in the missing value here. If 2 laps is how far you can go in 3 minutes, then Marcus can go 4 laps in 6 minutes. Those are equivalent ratios. Okay, so really every one of these can be written as an ordered pair. I have 2, 3. Write it as an ordered pair. I have 4, 6. Write it as an ordered pair. I have 6, 9. Write that as an ordered pair. So if I'm looking for which graph represents this table accurately, I need to find a graph that has points at 2, 3, 4, 6, and 6, 9. Let's look at this choice A. If I'm at the origin, 2, 3 would be 2 to the right and then up 3. Uh-oh. That's not on that line, is it? That's a miss right there. So it's not A. Let's try B. Is 2, 3 on here? Well, go 2 to the right, go up 3. Uh-oh. That's a miss also. Try C. Go 2 to the right, 1, 2, and up 3. 1, 2, 3. Uh-oh. That's a miss also. Try D. 2 to the right, 3 up. Oh, it's a direct hit. Does 4, 6 also land on this line? Well, you go to 4 and then go up 6. You're on the line again. Here's 6 right here. And 6, 9 is also on that line. So D is a match. Definitely graph D. And again, you find this by first looking at the table and then identifying with your input-output pairs. See how the input is X and your output is Y? You have your input followed by your output, X followed by Y. So 2, 3, 4, 6, 6, 9 falls on this graph right here. So it is choice D. Number 12, what ordered pair would be included on this graph if the graph was made larger? So let's find some points that are on this graph. I see the line passes right through this point here, right through this point here. It goes through this point right here. It'll go right through this point here. And let's see where those are located. This point is at 4, 1. This point is at 8 cups of flour for 2 cups of sugar, so 8, 2. This one here, we have 12 cups of flour to 3 cups of sugar. Over here, if we continued, we'd have 14, 16 cups of flour and 4 cups of sugar. You can see the pattern here. And so when you look at, excuse me, when you look at your options, 25 would definitely be on that line. Because notice every time if you take your cups of flour, 4, and divide by 4, you're going to get your cups of sugar, 1. So 4 divided by 4 is 1, 8 divided by 4 is 2, 12 divided by 4 is 3, 16 divided by 4 is 4, 20 divided by 4 is 5. See, 1, 4 is backward. 24 divided by 4 would be 6, not 8. 16 divided by 4 would be 4, not 5. So I can show these in a table as well. If your flour is your X and your sugar is your Y, and they are because that's where they are along the X-axis and the Y-axis, you have 4 and 1, you have 8 and 2, you have 12 and 3, you have 16 and 4, and guess what? You would have 20 and 5. Okay, so again, it's much easier to do a problem like this if you make yourself a table. So I would recommend that. Otherwise, just find points on your graph that the line is passing through. All right, here I have 6 candy bars. If 6 candy bars cost $4.74, what is the unit rate? Actually, it's a unit cost question. What is the unit cost? We always put the price in the top. So it's $4.74 for 6 candy bars. So the unit cost would be the price for 1 candy bar. That means I have to divide these. 6 divided by 6 would equal 1. So we have to take $4.74 and divide it by 6. The easy way to do this, of course, is just when you've written your ratio, $4.74 for 6 bars, just divide these. And when you divide these, I'll put my $sign, 0 point. Let's see what we get. 6 times 7 is 42. And then we have 54, so we're going to have a 9 times 6 is 54. We get 79 cents per 1 bar. So this right here is 79 cents per bar would be the unit rate or the unit cost. You will be able to use calculators on the test tomorrow, okay? So you wouldn't have to do this by hand or try to do it mentally. You can just plug it into a calculator and it comes out to 79 cents per candy bar. Number 14, at an average rate of 65 miles per hour, how far can you travel in 5 hours? 65 miles per hour, I can write that as a ratio, putting the miles in the top, the hours in the bottom of your ratio. Distance in the top, time in the bottom. So I have 65 miles in 1 hour, 65 miles per hour. How far can you travel in 5 hours? So if you want your time to be 5 instead of 1, well, you can see what you need to do. Multiply by 5. So we'll take 65 times 5, which is 260, 325 miles in 5 hours. Okay, so that's this one right here, 325 miles in 5 hours. We had to multiply. We know the distance in 1 hour, so then find the distance in 5 hours. Okay, multiply by 5. 65 times 5 is 325. All right, write this statement as a unit rate. We have 400 words typed in 5 minutes. So 400 words in 5 minutes. All right, if it's 400 words in 5 minutes, and I want to find the unit rate, I want to find how many words it would be in 1 minute. Some people call this WPM, for words per minute, when they're abbreviating it. But I hope you can see, oh, just divide by 5 then, to get from 5 minutes to 1 minute. Same thing here. So looking at 400 words in 5 minutes, you could have just divided this right away, and you get exactly 80 words in 1 minute. So that would be this choice right here, 80 words per minute. Okay, I'm going to stop in this video. I know there's a little more time here, but I'll do 16 through 20 in the next video.